All right, cool. Slides are mostly working. Excellent. So yeah, my name's Jethro Carr. I'm the systems architect at VFX Media here in Wellington. And you might know us for a small website called stuff.co.nz. So this was originally going to be an Ignite talk. Now, I have a suspicion that Will was a little bit concerned I was going to take it literally and asked me to turn this into a full talk and take up a whole slot. So unfortunately, there will be no fire today. I do apologise, Will. There will be some closure. All right, so Stuff.co.nz, if you're not from domestic, it's a popular news and lifestyle website here in New Zealand. Some of you might think it's unpopular, depending on your personal preferences, but you still read us anyway. 2 million unique visitors a month, so we're the biggest, pretty much the biggest domestic site. 5-person DevOps team. Our DevOps team's quite young an organisation. We're only about 2 years old on the New Zealand side of the business. But we have a benefit of a much older team in Australia that was sort of piggybacked from and stolen all the good bits from, learnt from, and developed from there. So I thought it's pretty important to define DevOps. I mean, you've heard some really good speakers throughout the conference. You've had good chats and open spaces about what is DevOps really. You know, is it about empathy? Is it about working with developers? Is it about code? Is it infrastructure? I can safely say they're all wrong. Because DevOps is something you do because Gartner said it's really, really cool. And you know that they're never wrong. It's a task to complete. You do DevOps, and then you're done, and you'll have cake. And they're really hard to catch DevOps engineers. From every recruiter I've spoken to, you've got a very short period of time to actually find any particular talent and make use of it. So, on a more serious note, there is a somewhat sliding scale of what might consider DevOps to mean. Traditional sysadmin at one far extreme and pure developer at the other. And I would say there's probably two key distinctions. You've got an infra code or SRE type person, someone using automation tools to build infrastructure. And then you've also got a term I think Will here coined, Dev Shepherd, someone who works closely with developers collaboratively to help build infrastructure and build solutions. I don't particularly love the Dev Shepherd term because developers aren't really sheep. They're more like cats. They don't really do what you want them to do most of the time, but sometimes they do things you want. And they're a little bit annoying at sometimes, but you also love them all the same. So maybe it should be like Dev Petter. I'm not really sure if that sounds right either though. Dev Cattle. So we're somewhat more on the infracoder side. We're primarily an operational team, so we're closer to that side of the game. We're slowly moving more and more towards Dev Shepherd. I think the reality is the nature of our role will always going to be quite infrastructure focused. We've also just recently introduced DevSecOps in our organisation, and I don't know where you put that on the chart. It's off to the side somewhere doing something special, but we've got high hopes for that role, and it's already working out really nicely for us. There's a lot more collaborative than traditional security team off on the side. This is someone who'll come and work with infrastructure, but also development teams to design security, secure solutions. So why infracoder versus a Dev Shepherd? Well, generally, you can drive change from your organisation from bottom up, but your change also, or structure comes from top down as well. And we've got a problem at VFX where we have a large proliferation of products. So you don't have one development team responsible for one platform. There's not the Stuff.co.nz team building the Stuff site. There is a team building the video player. There is a team building this widget. There is a team building this other thing. So it's hard to embed in that model where you've got to fill in all the gaps and look after systems that aren't necessarily allocated to any one particular development team at the current moment in time. So they're very, very tight focuses. We've also got a weird problem in that we're too big yet too small. If we were a small organisation with 1 or 2 dev teams, it'd be very easy for each one to have their own embedded operational resource working with them closely. But we're not so big that we can afford to put 2 or 3 DevOps engineers in every team and also have a core SRE team. So we're in that sort of in-between phase, which makes it kind of interesting. So a little bit about our team. We're primarily operational people. So that means late nights, coffee, lots of terminals. We're responsible for keeping the site online, and that's first and foremost the most important priority for us. We've not got a great ratio of developers to devs, with a lot of developers both internally and externally, relation of developers to infrastructure people. There's not heaps of us in relation to the number of developers throughout the organisation. And so we operate kind of an agency model where we act a bit like a consultancy internally or agency internally, where people come to us to solve problems. We work with them. That might be a particular ticket, it could be a project, it could be a long-standing engagement. We complete that work, we work with another team. And in many cases, some of the dev teams will engage with us very heavily in the early days, provision of infrastructure, give them the keys for the deployment system, and say, hey, have fun, you can release when you want. And then, of course, your engagement reduces with that team. And we have a sort of situation where there's software managed by several teams, software managed by one team, or the unfortunate reality of software managed by no teams, which kind of lands on mine. That's my favorite bit of software. Ideally, like I said before, I'd love to have like an organization where a dev shepherd's in every team and a core SRE type team in the middle. Reality is we're not quite big enough with enough money to do that. If you guys all buy Dom Post, that would help us considerably with this goal. No pressure. The other problems we have is that we've got lots of different vendors with different technology stacks. I mean, we go to vendors all the time for helping us with burst capacity, also specialist skill sets. But you just can't really go to your vendor and say, hey, we're hiring you for your specialist skill set, but don't use any of the normal stuff you use. You've got to use this other thing because you defeat the whole point. But it does also mean we have a large range of technologies that we have to cope with, and also different levels of experience. We've got vendors who are doing really, really innovative stuff with containers and cloud and all sorts of stuff. And then we've got vendors emailing us, asking us what an SSL cert is. So, you know, different ends of the spectrum here. We've got some beautiful historic platforms. You know, we deeply enjoy working with those, and that causes us absolutely no grief whatsoever. So we kind of bootstrapped this DevOps team about a year and a half, 2 years ago. And to do that, probably the key bit for us is figuring out how we're actually going to work together. We operate on a Kanban style process. It works really nicely for operational teams because, hey, this thing's on fire, let's bring it into the board, rearrange stuff. Every single thing's a ticket. That means a request to do a DNS record is a ticket, a request to build a whole new platform is a ticket, a request to help someone figure out a log on is a ticket, and we track all of our work that way so we can prioritize and measure and that sort of stuff. Generate analytics from how much work we've got going through the system. Works great for operational, not so great for long-running projects, but overall it's been a pretty good model for us. Your mileage may vary. I'm not an agile coach, I'm not selling you any methodologies. It works for us. Maybe it does for you, maybe it doesn't. The other key part for us has been pretty much waging a constant war against on-call. And it's probably the single biggest cause of burnout. And I've worked with teams that have really, really punishing on-call processes where you get paged several times a night, every time you're on call. And that's really going to burn out your staff. And part of the team here in Wellington, we've been really, really focused on trying to minimize call-outs with a goal, of course, of 0 call-outs. Not always possible, but the general philosophy is if you come in the next day, you got woken up last night, let's get a fix in place. I'll bump your other work, rearrange priorities as much as possible, let you focus on fixing the root cause or silencing the broken monitoring or addressing that. Not perfect, we have a few bad weeks lately thanks to some new projects, but historically we've been pretty quiet on the old call front. And just a shout out to PagerDuty, if you're not using a tool like PagerDuty in your organization, please, for the sake of your infrastructure people, get one. It doesn't have to be that tool, it has to be a tool that allows you to silence, reassign, acknowledge, schedule overrides, that sort of thing. And it's so much nicer than old school FMF on a cron job. So the other key thing in our organization was we had to figure out the commonalities of technology we're running. I mean, of course, everything requires compute, even so-called serverless systems kind of require some sort of compute to run. Most of our development teams are doing Java and JavaScript, so common cause there. And we had to look at what's common around our caching systems, our databases, our shared utilities, figuring out what to standardize on. The other thing we are doing is we made sure we heavily use off-the-shelf technologies. We're a small team, we're under time pressures, we haven't got a luxury of re-implementing monitoring ourselves using lots of custom open source bits and hooking it all together because we don't have that many hours in the day. So things like version control, deployment systems, monitoring, we're huge proponents of finding an off-the-shelf solution and grab it. Don't necessarily expose yourself to unfair or unrequired amounts of vendor lock-in, but often the off-the-shelf solution is the right choice. And the other thing we try not to do is not to get overly creative. You know, automate all the things is the thing we talk about a lot in DevOps. You always want to automate, but you can sometimes create an overly complex mess, and that's not so fun for the person who inherits that mess. And I can safely say I've written a couple of those messes, and at the time I'm like, this is some great Ruby code, guys, like this is amazing. And then someone else looks at it and goes, what the fuck is this mess? And in some ways a manual process would have been better, because at least you can understand what was going on. So, you know, always focus on automation, always try and get to be fully automated, but don't push something that's not quite ready for automation just yet. And the other thing is don't necessarily use just for new and shiny because it's available. We're a big organization, we need to be able to hire people with existing skill sets and technologies. And many of the classic techs like Nginx, Varnish, Java, they're still really, really good solutions. Sure, it's not, you know, Elixir or Golang or some other new shiny thing, but these techs still work really, really well for an organization which job is deliver websites. It's not the most tricky requirement, guys. So all that being said, that's a bit about our culture and our team structure. How do we actually deliver the content to you? So if we go from the very, very lowest level when you request an article, running on the cloud, yay, it's fantastic. Don't regret hardware and 4 AM disk changes. We're running entirely Linux. There is no Windows environment behind stuff.co.nz. I'll put my evangelist hat on and say yes. We run a much-loved enterprise CMS platform, and this powers pretty much the guts of the Stuff website. And it's a large Java CMS platform, consumes a fair bit of resources, but it's also responsible for generating millions of articles all the way back to kind of the start of the website. And yeah, it does cause us a little bit of fun and games at times. To make it actually work, we use Varnish. And Varnish is a really, really high-performance in-memory cache solution. Been around for a long time, written by a bunch of Norwegians for another media company. In fact, it's used in New Zealand by not only Fairfax, but also NZME for the NZ Herald and Radio New Zealand for their websites as well. It's pretty much the de facto choice if you're doing major website serving. It makes ELBs, and even ALBs to some extent, look a bit like toys, because this is a system that has essentially got a Turing-complete configuration language. You can do anything you want inside it. In fact, you can even do C code inside it if you're that way inclined. I don't like punishment that much, but you might do. So what sorts of stuff we do with Varnish? Well, we transparently handle failure on our website with that. If you access an article and the system decides to throw a 500 because the CMS is top-notch, we'll retry against another member of a cluster. And if we can, we'll transparently serve a successful response and mask our failure. Of course, that doesn't help us if there's a bug across the whole fleet, in which case it's always going to serve a 500 response. In that case, we have Varnish just casually mask the failure and serve a stale copy of the article. And because of this, we've never gone down. It's a neat technology. We use it to route traffic to different backends. What consists of DevOpsDays used to be a single CMS, and then became 2 CMSs as part of a migration, and now it's 2 CMSs and a billion microservices. But it's all under one domain, all going from the one caching layer, and then we just direct routes in different places, based on regexes and all kinds of behaviors. We use it to control our CDN, and I'll come back to that. And the other key thing I want to point out with Varnish is it's a traditional off-the-shelf product. It's been around for like, I don't know, 5, 10 years or so. It's not, the latest new shiny auto-discovery via etcd or console. But it doesn't need to be, because we've got things like PuppetDB, and we can just discover that data and generate config dynamically using these traditional tools that are really, really rock solid, using modern automation to actually get that information for them. So if I spin up a new CMS box, it automatically adds it to the Varnish backend. And in fact, we even do some stuff where, because the CMS is so great, it takes a number of hours to become warm after you launch a box. And in the old days, we'd launch it and then we'd run a warm-up script and you'd sit there watching it replay a whole bunch of queries, warming up the system before it finally become usable. These days, what we do is Puppet will automatically add the box into the pool as soon as it comes online, but keep the ratio of requests at about 1%. And then as the box starts performing better and better, we bump up the ratio until it finally hits 100%. So you don't have a box sitting there for 4 hours that's unusable. You have a box that's immediately usable, admittedly somewhat useless because it's so slow, but it does actually serve some amount of traffic for that time period. We have a CDN in front. I mean, this is pretty standard stuff. Any large website around the world will use a main CDN. Akamai is a really popular choice. It's like, no one got fired for buying Akamai. It's a pretty popular option. I mean, all credit to them. They do a ridiculous amount of traffic. I mean, we do like multiple terabits a second during busy periods on Akamai network. It's really, really solid. And we aim for about 90% cache offload. The only problem with Akamai is it was kind of built 10, 15 years ago, and they haven't really improved the management of it since then. So it's all point and click. Please lay out all your config rules. Okay, publish that. Okay, 1.5 hours later it's live. Oops, I broke the whole site and it's now down. 1.5 hours later, my fix is live. It's not the greatest way of doing infrastructure. And of course, we're an infocoder team. We use automation for everything. So what we've done is actually started using Varnish to feed Akamai a lot of the configuration and decision making that we care about. We say, hey, Akamai, cache this for 1 hour on your caches, but tell the users to cache it for 5 minutes. We can do all that sort of stuff from our back end, which makes life a bit easier. We're using Lambdas big time. We have no batch servers anymore. I mean, there's still cron jobs or quartz jobs inside applications, but there's no dedicated, this is the batch box and blessed it is, never touch it, never break it, please don't break it. We use it to do things like check mail reputation score, thanks to Will's closure work. We use it to do things like download a file from the vendor, chuck it in S3, One cool thing we're doing is, because of course Lambda is very event-based, we've got an S3 backed static server. Every time a user dumps a static file into the static server, we send a purge request to the Akamai cache, which means our Akamai config says cache everything forever. And only if something changes will we tell you to go and update the copy. So there's no having to go back and say, hey, has this been modified, has this been modified, has this been modified? Akamai will tell you if something gets modified, and that cuts down our traffic costs significantly. Web apps, we've just started playing around with Lambda and serverless applications. Having some challenges around maturity of the frameworks and tooling. Some experiments are underway. Really keen to get more into this, and it's just a matter of time, really. Increasing number of microservices. Now, it turns out writing all of our functionality in a single monolithic CMS wasn't the fastest way to develop. And I was really shocked when I learned this. So we started creating more and more microservices. But of course, with microservices, you start having a large propagation very quickly, and your standards and your tooling becomes really important. So we set about creating standards within an organization. And of course, there's this famous XKCD comic around standards. We didn't have 14, we had 0 or 100, depending on your point of view of what was a standard. So standards in our organization should be simple and reasonable. Everyone hates their 100-page security policy document someone gives you. You want something that's simple and easy to use, something you can respect. We want it to be shareable with vendors and internal teams, and we wanted flexibility where suitable. If someone's got a situation that's not covered by the standard, you shouldn't say you can't do it because it's not in the standard. You should say, I'll help you find a way of doing this in a way that makes sense for everyone. And of course, it means it grows organically as well. Our standard is a wiki page. We can keep updating that. If someone says, hey, Jeffrey, I've done this wrong, sweet, submit me a correction, please, and we'll move from there. So a standard isn't just, we're going to use Docker, therefore standard done. Your standard will be, hey, we're going to use Docker, and we're going to use this tool for build pipelining. We're going to use this tool for patch management. We're going to use this fleet scheduler, figuring out how you actually want to do the overall solution from start to end. So at Fairfax, we're using the 12-factor app. If you're not familiar with it, check it out. It's a really good bunch of standards. And it's also great because it follows very nicely into containerization as well. We've got 3 languages, Node, Java, Ruby. That's because historically we're a Java shop, corporate CMSs, you love your Java. But of course, a lot of developers were doing JavaScript on front end, and Node made perfect sense and transitioned into being back-end developers as well. We have Ruby as well. Big vendor of ours uses lots of Ruby. And we started looking at defining common dependencies as well. Are we going to use MySQL or Postgres? Are we going to use MongoDB? If someone wants MongoDB for 10 meg of data, should we just say use SQL instead, even though it's not as great in certain cases? That's the sort of questions that we address and answer with these standards and process. Standardize our build pipelines. I've worked in organizations where you have a bash script, a gulp script, a Ruby script, a script of a language I've never seen before to deploy your software in all different weird and wonderful ways. We standardized around a pretty conventional pipeline of pushing to Git, pushing to a build system, and then pushing out to our server infrastructure. CodeShip's awesome, by the way. We're using it to push to S3 for static-only apps, Lambda, EC2, Docker registries. We're pulling and pushing stuff to Nexus all the time with it. But there's tons of other options on the market as well. You can do the same stuff with Jenkins quite happily. Infrastructure team, naturally we standardize our server builds, CloudFormation everywhere, auto-scaling, using Puppet quite a lot. And I'll talk a little bit more about Puppet, that's where it's interesting. Everything is automated with Puppet. So I mentioned before that we're sort of a spin-off of the AU organization. And if you look at the start of Puppet rollout there, we've been doing Puppet for 5 years now. All the way from Puppet 2, which was a little bit suboptimal. And we use it to provision everything from system boot to a fully running application. I can take the Ubuntu AMI and build that all the way up to a fully running application server with software deployed on it. Now, of course, that's not very fast, and you can Packerize it to speed it up, that sort of thing, but it means we've always got continual or ability to rebuild on new versions of the operating system or new base platforms. We've just recently started to use it to build Docker containers. I talked a little bit about this in the open space, but essentially we've got some really nasty platforms that take hundreds of lines of Puppet manifest to build out. We want to Dockerize them for easy developer use. And so it makes sense for us to be able to say, hey, Docker, build this container by running Puppet, build everything out using our existing tooling, and then clear out Puppet and provide a complete container at the end of it. So we've just started experimenting with that, and it shows some pretty neat promise. Standardize the software deployment. I've got a whole talk about this. I'll link to it later on. If you're interested, we're using code deploy to deploy Ruby apps, Node apps, and Java apps in a standard way in our environment, and that will roll out across the whole fleet. So we can deploy, other than the beautiful CMS that has no problems, as I mentioned before, we deploy multiple times a day on any other bit of software if you want to. It's a case of push to a branch and it'll roll out. Developers don't have to come and say, hey, Mr. Ops guy, can you please release our node code? It's just, you want to release code? Sweet, do it, boom, live. It's really, really nice. One key thing to note here too is we pull all of our secrets and credentials from Puppet. So we can store all of our creds, like DB creds or API tokens inside a secure store and then push it out to the server when we actually deploy. So there's no credentials floating around Git repos and that sort of fun stuff. Well, no intentional. I mentioned briefly init systems. We had a huge problem for a while with propagation of init systems. People writing stuff in sysv init, upstart. Hey, I like to do my stuff in God on Ruby. I like to use supervisor D. We've kind of been clearing out a lot of those. It's not perfect yet, but the problem we're having is it made it tricky to manage the handling of logs and also process failures. One case in point, PM2. We were running PM2 with Upstart because we run Upstart for all of our processes, and PM2 wouldn't realize that the node processes had died, and of course, since PM2 was still running, Upstart wouldn't kill it, which made life a little bit tricky. Whereas if we just run everything directly with Upstart, we know exactly how it's going to behave, how it detects failure, and it works quite nicely for us. Everything follows your standards. Life's perfect. I'm bored now. Yeah, there's a few challenges. I mean, there's always exceptions. Anything prefixed with enterprise is always terrible for automation and DevOps. Always. My favorite phrase currently is, hey, we just purchased this thing. Beautiful. And my true story, we found the Lotus Notes box and we wanted you to have it. Thanks, guys. Love you. And it involves a lot of work to get rid of exceptions. I mean, there's always an innate trend as an infrastructure person to say, oh, fucking product, why did they give us this horrible mess? But product don't know that Lotus Notes is a mess. They just go, oh, we found a server. You guys do server stuff. So you've got to work closely with a business to try and educate them. And it's never a one thing. You can't just say, hey, business, here's the standards doc, please read it. Thanks, bye. It's constantly talking with them. And you're always going to have a few things that fall through the gaps. Try and get involved early as possible and also set reasonable boundaries. Don't be a dick about it. I kind of drew the line at Lotus, but if you find some PHP thing, I'll probably help you run it. So that's my talk. I'm going to run out of time. I've got this link here. It's definitely not clickbait. There's a whole bunch of other links inside that, because I don't want to write them all on the slide. I'm more than happy to chat about a bit more about what we're doing. I've covered a lot of little bits of everything at stuff. I'm happy to talk about technology. I'm happy to talk about culture. I'm not going to talk to you about comments and the issues you have with them. You can follow that editorial. Brilliant. Well, thank you very much, and I hope you enjoyed it.
Let's ask Jethro a question.
Yeah, I forgot question time. Turn it back on. Here we are.
Was it just perfect?
I was going to run away.
Hi, I was just going to ask about your sort of pull request workflow, or whether you use any kind of peer review.
Yeah, it's a good question actually. So in the infrastructure space, we use pull requests really heavily, to the point that it replaced a traditional change ITIL process for most of our changes. So pretty much every day, my colleagues will say, "Hey, Jethro, I've got a pull request for this Puppet DS, for this Puppet manifest." We've got a policy. We try and have always 2 people approve it, and we try and mix it up. Like everyone on the team gets it: junior engineer, senior engineer. I've got junior guys questioning what I'm doing, which is great. You've always got to justify, hey, I mean, it's easy to get sloppy, particularly as you get senior. You start going, oh, well, I can't bother figuring out good rejects because I've got a meeting in 5 minutes, so here's just 4 if statements in a line. And one of the younger guys will be like, you've made a fucking mess, Jethro. And I'm like, yeah, I'm sorry. And you go fix it, right? And it's a great culture that you can actually have those conversations. But yeah, huge fan of PRs.
And what about where do you test changes?
So we've got pre-production environments for that sort of stuff. So you can push to pre-production, validate there before you push to production. Ideally, we want to have everyone be able to run applications locally. Easier on the Node stuff and the Ruby stuff. Big CMS platform a little tricky, and that's why we're doing a lot of work with Docker at the moment, trying to make nice images so we can say to someone, hey, here's a complete environment of Elasticsearch and databases and all this sort of stuff on your machine, and away you go. Not there yet, but we're getting there slowly.
Hi. Could you share how do you handle the disaster recovery? For instance, if the code chip crashed in one AWS region.
So if code chip crashed in one AWS region, how would we handle that? I mean, code chip, if it goes down, it blocks our ability to deploy software, but all the systems continue to run perfectly fine. We do have a documented process to actually push software manually into our systems if need be, because code chip just triggers a push against code deploy. Now, in a hypothetical situation, if code ship was down and we had an emergency patch that we had to get out right now, I can do a build locally. I know how to build it. I can package it. I can push it to code deploy and it'll roll out using the exact same deployment system that we always use. So we can take gaps of the automation if we ever had to. In terms of general DR, we've got a whole bunch of systems that back up data amongst the clusters. We've got 2 different AZs, so we can lose any one AZ, but we've also got all the copies of all the snapshots, databases, that sort of thing, just like most other organizations would. Hopefully that answers it.
Okay, thank you.
Hi, you talked about multiple dev teams. So are they like project specific or product specific?
So our teams are project specific. So a project might be build a new widget on the homepage, and that team's focused on that project. Personally, I'd be more of an advocate for having your development teams own a product, because you can do that close collaboration that we always talk about. If you want to do dev shepherding with developers, have as much responsibility of infrastructure as your infrastructure people, you kind of all need to be on call. You kind of all need to own that whole platform, whereas we don't have that currently, so we do have a distinction. I mean, I don't love the concept of DevOps team. I know that's a dirty word amongst some people here, but in our model, it's kind of the only real way of doing it currently.
We are evolving to that.
Yeah, we continuously evolve and continuously change. The way organization looks now did not look that way 2 years ago, and it will look different in 2 years' time again.
Hi, you told us that you use Puppet everywhere.
Yep.
You also test your Puppet code automatically or just manually?
Yeah, so Puppet stuff's a little bit shameful. So one of our new hires recently goes, "Oh, what's the unit test for this Puppet code?" And I'm like, "Yeah, good question. Let me know when you find it." So at the moment, most of the testing with Puppet takes place in pre-prod environments. So we've got multiple pre-prod environments, so you push to one of them, validate, push to the other, validate, push to production. I'm actually not a huge fan of unit testing Puppet itself, because the problem with unit testing Puppet is your Puppet DSL says, make a file appear, and your unit test says, did a file appear? It doesn't actually tell me, does Java run at the end of that? If I was going to start investing in testing, which is something I want to do a lot more with Puppet, is I'll be looking more at service spec, where I measure the result of a running machine and go, is Java running? Is it on port 8080? Can I connect to it and health check it? Because that's really the measure of success of Puppet. It's monitoring and it's not monitoring. I mean, you could actually, it's a lot of overlap, but it's measuring about what's the actual result of the system. I mean, usually people's monitoring is a little bit basic, right? I mean, you've looked at most Node.js setups people do, and it's like, is a port responding? Is a health check responding? It doesn't actually tell you, what else is going on the machine. That's quite rudimentary. Service spec can do that, but it can also get really, really pedantic about every single thing you want to test. I think there's a better model with Puppet, because otherwise you write a Puppet module that's 100% unit test passing with complete test coverage, and then it works perfectly fine on Fedora, and you drop it on Ubuntu and it's completely useless. And I think service spec's a much nicer measurement for that. Our code, it mentions a lot better. The development team do actually do unit testing to about 80 or 90%, so it's a much better example of best practices there.
So while we're talking about testing, do you use any automated performance or security testing?
Yeah, performance testing's a tricky one. I mean, we do occasional testing of the www site. Mostly we operate on comparison basis. So we measure releases before and after different versions and see what the impact is. It's an area I actually want to do a lot more work in, but it's actually really, really tricky to find performance testing companies and people who can actually do a good job. A lot of times I've spoken to performance testing experts that goes, oh, well, I just run A/B lots. And I'm like, well, I can run A/B lots too, but I can't simulate the pattern of a user doing a whole bunch of weird stuff in some JavaScript-only application. That stuff's really hard to test. Serving X number of articles per minute, that's easy. Just run A/B on it. We use New Relic APM really heavily. It costs us a small fortune, but it is a fantastic tool, and the introspection of that platform is just brilliant. If you're not using an APM tool of some kind, I strongly recommend you get down that path. I mean, I've done the old school debug performance by strafing the process and TCP dumping it and seeing how long the DB responses are. That's not fun. Just buy a New Relic, drop it on there. Makes life a lot nicer.
So how do you guys go when a developer has a request for a particular tool to be used instead of your standard?
It's a question of what's the reasoning for it. And it's like sometimes it's a case of, I like this tool a lot, can we use it? And it's like, well, no, we've got a standard for a reason so everyone understands the tool. But if the request is, hey, I need to use this particular caching technology because it solves my problem in a unique manner, that's fine. We'll have a discussion and we'll roll it out. It might be an exception to the standard, or it might be actually, this is something we want to roll out everywhere in the future. So it does depend. It's a case-by-case basis, and there's no solid, we will do that or we won't do that. I mean, big organisation, you've got 30-odd people on the technology team. You kind of have to be a little bit more rigid about standards just because you don't want for one person coming in and going, I really, really love doing everything in Ansible, and we've got one person in the team building all this Ansible stuff when we're a puppet shop and then leaving. That's something we won't accept, but we might accept evolution as to what we're doing.
Okay, so you touched on this sort of briefly in the talk, but so you automate everything, and then in the middle of the night the page goes off and the automation's broke and you need to do something. How do you solve that so when the juniors come in and all they've done in the past is press a button and the automation handles everything?
Sure. So we're quite good at documentation. I'm particularly pedantic about it, and the rest of the team is actually pretty good as well. Everything's documented. So if I look up how the hell does this code ship integration actually work, there's a full page about it. Here's how it's set up. Here's how it connects. We're very, very pedantic about building like readme.md files in all of our repos. It's probably one of the most documentation-heavy teams I've worked in before. And I think it's been reasonably successful. Like new starters have joined and said, actually, I know a bit about what's going on. Not saying it's complete. It's like unit tests. You never have full documentation coverage, but you have a fair bit of it. And that's worked pretty well. Tim, did you survive your first week of on-call? Just, yeah. So it's all good, right?
So how do you deal with juniors and interns and everything integrating with the team?
Oh, straight on call first day. Got haze them. We try not to make the distinction so much. Like, it's not, okay, you're a junior, so you can get all the shit tickets the rest of your life. So, someone comes on who's got less experience, you'll give them work that's easier to get into, and, we do cherry pick the tickets of the new staff members that are easier to understand a bit about what our environment's doing, and sort of get to learn stuff. But it's really about capabilities, what are you good at? As soon as you start showing promise and you're good at Puppet, we'll move you into doing Puppet work. And you work closely with the team. There's no like, okay, the senior can do all the project work and you can't. It's, hey, you want this project? Sweet, have fun. We're here to help you out. Come talk to us as you need to. So it's much more of it's a team of people working together. It's not a chain of seniority dictating to each other what's going to happen. I like to figure that anyway. My staff might disagree. Ask them when I'm not here and see what they say.
I might comment on that later.
Don't trust them as a trader.
Right, well, thanks very much, Jethro. That was
Thank you, Will.
awesome. Brilliant.
Cheers.